So for stoichiometry, we're going to use the balanced equation, but it's a little beyond that. Stoichiometry in general, we're saying, so if I have a specific amount, right, like 7.2 or something like that, right, 7.2 moles of hexane. Well, that's hexane, but I should use the chemical formula. Make life easy. I have some odd amount. How much of something else, right, would match with that. So how much oxygen would I use? How much water would I make? How much carbon dioxide would I make, right? So it's just a unit conversion. There's nothing fancy about that, right? So I let the units guide me. I have moles of hexane. So I just go and I get 2 moles of hexane. And then whatever I want to go to, right? So let's say the problem asked me about how much oxygen. The words around that would be how much oxygen would I use? So then I put 19 moles of oxygen right here. So we say, well, our 7.2 moles of hexane cancel out with our 2 moles of hexane. So 7.2 times 19 divided by 2. So that's 68.4 moles of oxygen. As we start to get into more quantitative stuff, amounts matter a little bit more. We'll see in the lab that really, if I have 2 measured values, then I should record my answer to 2 measured values, right? So that's kind of an idea of significant figures that we're going to get into. So since I have 2 measured values here, and these aren't measured, these are defined values, so I can ignore them, then the best way to record my answer would be 68 moles of oxygen, right? Would be the best way to record that, because then we're doing similar amounts of precision on that. Let's set up another one and maybe have you work ahead of me on that one. Let's say I want to produce 0.000637 moles of water, or molecules of water, right? It's moles or molecules, but not grams, not liters, not, it's count amounts, not measure amounts, right? So if I have that many moles of water and I want to know about, if I want to make 0.00637 moles of water, how much, let's say, carbon dioxide will I also produce? How many moles of carbon dioxide will I also produce? Maybe try and work ahead of me on that one. So again, I just go, what's the ratio? Well, my ratio is 14 and 12. Right? Because I'm talking about water and carbon dioxide. Then I just have to figure out which one goes on top and bottom. Let the units help you there. Your natural instinct is to go numbers first because you want to get the answer, right? But if you let the units help you on that, you'll be much better off long term, right? So I'm going to put the 14 on bottom because I want the moles to cancel, the moles of water to cancel. So 14 moles of water for every, and I'm trying to color code here so we can see where stuff's coming from, for every 12 moles of CO2, right? So we can do this anytime we've got moles or individual molecule atom type things. We can't do this with grams and stuff. That's kind of what we're getting into. When we do grams, then we have to do more steps. So I would do 0.000637 times 12 divided by 14. So it should be a little bit less than that, right? So 0.00546. 0.00546. So hopefully that helps with just our one-step mole-to-mole stoichiometry.